In this video, we're going to be extending the concept of radical equations. And they give us a reminder of the radical equations that we've dealt with in previous modules. In number one, they want us to find all real solutions to each equation. In A, we have 4 minus x divided by the square root of x squared minus 8x plus 32 is equal to 3 divided by 5. And it asks, is this a proportion? And the answer is yes. And it's yes because we have a single fraction on both sides, so we can cross multiply. And now they want us to cross multiply. So we have 4 minus x times 5 is equal to 3 times the square root of x squared minus 8x plus 32. And now they want us to simplify. So we're going to distribute the 5 through the parentheses, and we're going to have 20 minus 5x is equal to 3 times the square root of x squared minus 8x plus 32. And now it asks, what form is the resulting equation? And we have form B. If we look above, we have one radical term and one polynomial on each side of the equals. So it's telling us to square both sides. So it wants us to solve now. So we're going to square both sides. 20 minus 5x squared is equal to 3 times the square root of x squared minus 8x plus 32, all squared. And we have a perfect square trinomial on the left. So we're going to have 400 minus 200x plus 25x squared is equal to 3 squared is 9 times the square root of x squared minus 8x plus 32 squared is equal to x squared minus 8x plus 32. And now I want to distribute my 9 on the right side of the equals. So we have 9x squared minus 72x plus 288. And now I'm going to move all of my terms to the left side of the equal sign. So we have 25x squared minus 9x squared gives me 16x squared. And then I have negative 200x plus 72x is minus 128x. And then I have 400 minus 288 is equal to 112 is equal to 0. And now I'm going to factor a 16 out. So I get 16 times x squared minus 8x plus 7 is equal to 0. And now I can write this as linear factors. So I have 16 times x minus 7 times x minus 1 is equal to 0. So my possible solutions are x is equal to 7 and 1. And now we want to check for extraneous solutions. So we're going to plug x is equal to 7 back into our original equation. And we'll have 4 minus 7 divided by the square root of 7 squared minus 8 times 7 plus 32 is equal to 3/5. And now 4 minus 7 is negative 3 divided by, we have the square root of 7 squared is 49 minus 8 times 7. 8 times 7 is 56. So we have 49 minus 56 is negative 7 plus 32 is 25 is equal to 3/5. And then we have negative 3/5 is equal to 3/5 is false, so it will not be part of our solution set. And if we plug x is equal to 1 into our original equation, we'll have 4 minus 1 divided by the square root of 1 squared minus 8 times 1 plus 32 is equal to 3/5. 4 minus 1 is 3. And then we have the square root of 1 minus 8 is negative 7 plus 32. So the square root of 25 is equal to 3/5. And 3/5 is equal to 3/5. So this is true. So our solution set for problem A is 1. In B, we have 1 over 3x plus 6 to the negative 1/4 minus the fourth root of 7x minus 6 is equal to 0. And they want us to begin by writing the first term as a radical. So if we were to write 1 over 3x plus 6 to the negative 1/4 with a positive exponent, it would be 3x plus 6 to the 1/4. And we want to write it with a radical. So we're going to have the fourth root of 3x plus 6 minus the fourth root of 7x minus 6, and that's equal to 0. And then they ask what form is the resulting equation. And here we're in form D, and we have two radicals. So now we want to solve. And when we have two radicals, we're going to put one on each side of the equal sign. So the first thing that I'm going to do is rewrite our equation with one radical on each side. So I have the fourth root of 3x plus 6 is equal to the fourth root of 7x minus 6. And now I'm going to raise both sides to the fourth power. And when I do, I get 3x plus 6 is equal to 7x minus 6. And now I'm going to subtract 3x from both sides and add 6 to both sides. I have 6 plus 6, and that's equal to 12. And 7x minus 3x is equal to 4x. And then we're going to divide both sides by 4, and we get x is equal to 3. And now we want to make sure that 3 is not an extraneous solution. So we're going to plug 3 into our original equation everywhere where there's an x, and we're going to make sure that 3 is a solution to our equation. So we have the fourth root of 3 times 3 plus 6 minus the fourth root of 7 times 3 minus 6 is equal to 0. And now 3 times 3 is 9 plus 6 is 15. So we have the fourth root of 15 minus 7 times 3 is 21 minus 6 is 15. The fourth root of 15, and this is equal to 0. And the fourth root of 15 minus the fourth root of 15 is equal to 0. So our solution set is 3. In C, we have the square root of x plus 16 minus the square root of x is equal to 2. And it says, at first glance, what is the form of this equation? And at first glance, we have form A, which would be one radical and one constant. And now they want us to square both sides. And if we square both sides, we get the square root of x plus 16 minus the square root of x is equal to 2 squared, and 2 squared is equal to 4. And now it wants to know what is the form of the resulting equation. And here we're in form C. We have 2 radicals and 1 constant. So now in order to solve it, I'm going to add the square root of x to both sides. So I have the square root of x plus 16 is equal to the square root of x plus 4. And now I'm going to square both sides. And when I square both sides, I get x plus 16 is equal to the square root of x plus 4 squared. And this is equal to x plus 16 is equal to, and here we have a perfect square trinomial. So we have x plus 8 square root of x plus 16. And now I'm going to subtract 16 from both sides, and I'm going to subtract x from both sides, and I'm left with 0 is equal to 8 square root of x. And now if we divide both sides by 8, we get the square root of x is equal to 0. And if we were to square both sides, we would end up with x is equal to 0. And now we want to check 0 in our original equation. So we have the square root of 0 plus 16 minus the square root of 0 is equal to 2. And now 0 plus 16 is 16, and the square root of 16 is 4. So we have the square root of 4 and minus the square root of 0 is equal to 2. 4 minus 0 is equal to 4, so we have the square root of 4 is equal to 2. And the square root of 4 does equal 2, so our solution set is 0. And that's our video on extending the concept of forms of radical equations.